Hey everybody, Swarsky here. Let's just get this MCA warm-up, let you go through a few. I figure I'll hit a couple of these a week just to kind of bring back in our minds. It's been a while since we've done this, or we might not have seen it just from the crazy year that we've had. So I just want to give you an opportunity to see it. The first piece here, also, if you are in 7th grade, I apologize. My focus is going to be on the 8th grade MCA. So yours is going to be more on proportions and linear equations. So if you have questions, 7th graders, let me know and I can direct you in the right place. But for right now, these warm-ups will be focused on the 8th grade MCA kind of topics and everything like that. So moving forward, we're looking at arithmetic geometric sequences. Now maybe you've heard of that, maybe you haven't. Basically what you're looking for, arithmetic is a set of numbers that has a common difference. It's being added or subtracted at a consistent rate. Linear. Geometric is simply just another way to say that it has a common ratio, or it's being multiplied or divided by a common amount. Also thought of as a exponential value, where it goes up pretty fast. So what I'd like you to try, just with that little thought, with that little kind of description, see if you can figure out which one of these is arithmetic, geometric, or neither. There's a little bit in there anyways. And if you're a step ahead, or if you really want to try it, the ones that you do define as arithmetic or geometric, I want to know what the common difference or ratio is, meaning what is it being added or subtracted by, or what is the common multiple or common division by. Try it out. Pause the video, see what you can do with this, and then we'll come back. Okay, with these next ones here, so the first one is arithmetic. Let me get my deal here. I would say this is arithmetic. Here's why. If I subtract this, you're going to see that each time I'm subtracting 3. Okay, so because I'm minus 3, it's arithmetic, and the common difference in this case is -3. The next one actually has no arithmetic or geometry, has no common ratio or difference. If I try doing the difference, it's being the first one's being added by 2, then by 3, then by 4. Well, that doesn't work. And I can't multiply. There's not a common multiple that will give me that, so that's a neither. Next one is geometric. We'll give that a big old G. And the geometric, that means it's being multiplied or divided by a constant rate. A way to figure that out, if you think, is take this one here and divide it by the one before. If I were to do that, -5 divided by 1, I get -5. So I'm saying I'm multiplying by -5. If I do it again, 25 divided by -5, guess what? I get -5 again. I'm seeing kind of the pattern. -125 divided by 25, that's another -5. So the common ratio is that it's being multiplied by -5. Next one also is geometric. The common ratio here is starting at -2 would be times 2. Each time, -2 times 2 is -4, times 2 is -8, times 2 is -16, and so on. So the common ratio would be 2. Number 5, it is an arithmetic sequence, which means it has a common difference. Each time it's subtracting 10 minus 10 minus 10. So the common difference is -10. Next one, geometric, and that would be because it's being multiplied by 4 each time. And finally, the next one has nothing. That is another neither. Okay, if I tried adding, I see it's +6, and then plus 9. Doesn't work. And then I can't multiply. It's times 3, then times 2, then times 3. So that has a neither. Now, the only one I didn't show is the geometric if it's being divided. So I can do the same thing. If I saw something like this, 64, 36, 16. If I went the other way, so big to small, I realize in this case I'm dividing by 4. So the common ratio, this is still geometric. The common ratio is, if it's dividing by 4, the common ratio is 1/4. Okay, it's always being multiplied. But that's the options there. That's all I got for you with those. Hopefully you get a little bit of a wake up with what arithmetic and geometric is. Other than that, I'll see you on the next video, everybody.